In this lecture, we are going to learn how we can build our own logic to display a pyramid pattern like this. Okay, so in this lecture, we're going to learn in details how we can devise our own logic using pen and paper, and then we're going to write a computer program to demonstrate the same as well. So let's get started. So in order to solve any pattern problem like this, step number 1 is to observe how many number of lines are there in this pattern. So if you just look at this pattern, in this pattern there are 5 lines. Okay, there are 5 lines. And now because I need to run a loop that takes care of each line, I can use a variable to indicate each line. So here I am assuming that I equals to 1 indicates line number 1, I equals to 2 indicates line number 2. Similarly, I equals to 5 indicates line number 5. So step number 1 is done. We have noted down the number of lines in this particular pattern. Okay, and now what is available in each line? What are the components of each line? This is very important. You need to note it down. Okay, so first of all, if you see in each line, in first of all there is something called as spaces. Okay, so there's a space, right? So in line number 1, you see there are 4 spaces here. These yellow boxes represent a space in this example. Okay, so there are spaces in each line. Okay, so first you start a line by printing spaces. Then what do you have next in each line is you are having some values to be printed. Okay, in line number 1 there is a value 1 that is being printed. Okay, in line number 2 there are 3 values, that is 2, 1, 2. These values are printed. So after you print spaces in each line, then you have to print all the values of that line. Okay, and finally what you have in each line is a new line character. So you need to finally print a new line character. Okay, so these are the 3 components of each line. First you print spaces, then you print lines, and then you print a new line character. So these are 3 components of a line. Now finally what you have to do is you have to find out in step number 3 what is the relationship between line number, because line number is my outer loop, right? Line number is a loop that takes care of my line. Okay, now this is the outer loop. Now you need to find out the relationship between the line number and number of spaces, and line number and number of values. Let's assume that line number is represented by the variable I. Okay, so I represents line number, J represents number of spaces, and K represents total number of values to be displayed. Alright, so let's try to find out the relationship between, first of all, between line number and number of spaces, that is between I and J. Okay, so let's try to note it down here. So in line number 1, there are 4 spaces. Okay, in line number 2 there are 3 spaces. In line number 3 there are just 2 spaces. In line number 4 there is 1 space, and in line number 5 there are no spaces, so there are 0 spaces. Now what is the relationship between line number and number of spaces? If you just note it down here, line number, in line number 1 there are 4 spaces. So if you do 1 plus 4 you get 5. Okay, similarly in line number 2, this is 2 is the line number, there are 3 spaces. 2 plus 3 equals to 5. So if you add a line number I with total number of spaces in that line J, it has the sum as 5. Okay, so from this I can conclude that my J is equals to 5 minus I. So this is the relationship between the line number and number of spaces. That means if I already know how many lines are there in my pattern, I will be easily able to find out how many spaces are there in that particular line. For example, in line number 3, I is 3. Okay, how many spaces are there in line number 3? I just write 5 minus 3. 5 minus 3 is 2. So in line number 3 there are 2 spaces. So this, using this formula, you can actually do a mapping between number of spaces and line numbers. So what is the relationship between I and J? I can write J is equals to 5 minus I. So first of all you need to note down the relationship between line number and number of spaces. It's very simple. Now let's try to find out the relationship between line number and total number of values. In line number 1, how many values are there? There's just 1 value to be printed, that is the number 1. In line number 2, how many values are printed? There are 3 values, that is 2, 1 and 2. So there are 3 number of values to be printed in line number 2. In line number 3 there are, count how many are there, 1, 2, 3, 4, 5. Similarly there are 7 in line number 4, and there are 9 in line number 5. Now how can you do the mapping between line number and number of values? Okay, so how do I do the mapping? Okay, so if you just take one scenario, in line number 3, total number of values are 5. In line number 4, total number of values are 7. So if you just look at this, this is the input. You just have this line number with you. So from this, you need to generate this output, 5 and 7. Okay, so let's take this scenario. In line number 4, there are 7. So 7 is nothing but twice of 4 minus 1. That is 8 minus 1, which is equals to 7. Similarly, 5 is nothing but 3 times 2 minus 1. 6 minus 1 is 5. Okay, so if I have 3 as an input, how do I get 5 as the output? I write 2 times 3 minus 1. Okay, so if I have I as the input, what is the output? 2 times I minus 1. Okay, so this is the relationship between I and K. Okay, so I can write K is nothing but 2 times I minus 1. Okay, you can just do this for any example. Let's say in line number 5. So what is K? Total number of values. So what is K in line number 5? In line number 5, to find K, first I need to know what is I. So in line number 5, I is 5. So instead of I, I'll put 5. So 5 times 2 is 10. 10 minus 1 is 9. See, in line number 5, there are 9 values. So relationship between K and I is K is equals to 2 times I minus 1. Okay, so it is very important for you to find out this relationship. Once you find out these relationships like this, it will be easier for you to put all these things in a loop. So let's put this in a loop now. Now we have already noted down the relationship between J and I and K and I. Okay, so now the outer loop. What is the outer loop? Outer loop will take care of lines. Okay, so outer loop, this white colored one, I is 1 initially, line number 1. Okay, I must be less than equals to 5 because I have 5 number of lines in my pattern, and I plus plus. This is the outer loop. Okay, now what do you have in each line? In each line, first you will have to print spaces. So you have to write a loop here in this box to print all the spaces in that line. And then in this blue box, I'll have to write my code or a loop to print all the values. Okay, and in the red box, I'll have to write a code to print a new line. Okay, so these are the 3 things that I repeat for 5 times. Okay, and this number of spaces in each line is different. Number of values to be printed in each line is different. And every time I print a single new line for each line. So that's what you need to take care of. So now let's write a code for number of spaces. Now how do I know how many spaces are to be printed? It's very simple. I know there are 5 minus I number of spaces to be printed because I already have I from the outer loop. So I'll run an inner loop. Okay, for j equals to 1. Okay, j must be less than equals to 5 minus I. Already we have found out this relationship, j plus plus. Okay, so this loop will run for 5 minus I times in that line number I. So I need to print a space in this body. Okay, printf. So I just give double quotes. This will print a single space for me. So this is very simple. Printing space is done. Okay, now I need to write a logic to print all the values in that particular line. Now to print the values, let's take an example of I equals to 3, that is line number 3. In line number 3, if you note down, what are the values that is being printed? In line number 3, these are the values that I am printing, that is 3, 2, 1, 2, 3. Okay, now if you observe this closely, okay, now this is decrementing and this one is incrementing in nature, right? So these 2 values are incrementing in nature and these 3 values are decrementing in nature. So while I write this loop, I need to take care of these things as well. Okay, but I already know how many times I need to run this loop that will print the values. I already know there are 2 times I minus 1 number of values to be printed. So I'll write a loop here. Okay, so the loop here goes like this for, okay, k equals to 1. Okay, k must be less than equals to 2 times I minus 1, and then I write k plus plus. Okay, so this is my loop to print all number of values. So how did I find this 2 times I minus 1? We have already done in the previous slide. We found out the relationship between the line number and total number of values to be printed. So this loop will run for total number of values to be printed in that line. Okay, but to print a value, I have two patterns coming up here. One is decrementing number and one is incrementing number. Okay, like in case of I equals to 3. Okay, whenever I equals to 3, what is the value of k that is ranging from? K will range from 1 and it will go up to 2 times 3 minus 1. So 6 minus 1 is 5. So it will go from 1, then 2, then 3, then 4, then 5. But I am not supposed to print k here. That is the point that you should note. What I am supposed to print are the values v. What are the values that I am going to print? The values that I am going to print are 3, 2, 1, 2 and 3 as displayed here. So what I have is k, but what I have to print is the value v. Okay, this is for the case of I equals to 3. Okay, but in this case, the value that I am printing is, here the value is decrementing, these three values are decrementing, and these two values are incrementing. Okay, now we may have to have a different logic for decrementing values, and we may have to have a different logic for incrementing values. Okay, so from 1, how do I get 3? Or from 2, how do I get 2? From 3, how do I get 1? So this is the decrementing value. Okay, so if you look at this, if you just look at this, I can write k plus v is equals to 4. If I just see here, 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4. Right? So from this, can I write my value that is to be printed is 4 minus k? I already have 4 with me. So the value to be printed is 4 minus k. Okay. Now let's try to verify the same with a different value of I as well, because we need to be ensured that it works for all values of I. So whenever I is 4, what are the values that is to be printed? Whenever I is 4, k ranges from, whenever I is 4, what is the value of k? K would be 2 times 4 minus 1, that is 8 minus 1, it will be 7. So it will go from 1, 2, 3, 4, 5, 6, 7. But what are the values that is to be printed whenever k is 4? The values to be printed are 4, 3, 2, 1, 2, 3, 4. So it is 4, 3, 2, 1, 2, 3, 4. Whenever k is 1, the value to be printed is 4. So in the same case, if you do k plus v here, I do not get 4. In the previous case, whenever I was 3, I got 4. But whenever I is 4, I am getting k plus v as 5. 1 plus 4 is 5. 2 plus 3 is 5. Okay. 3 plus 2 is 5. 4 plus 1 is 5. Okay. But I am not talking about the decrementing values. I am not talking about this 3 values. Okay. I am just talking about this half portion of the pattern. Here also I was talking about the half portion of the pattern. We'll talk about the next half after some time. Okay, so k plus b here is 5. Now this is not exactly 4, right? This is actually, how do I get this 5 is, it is 4 plus 1. Okay, this 5 is nothing but 4 plus 1. And this 4 is nothing but I, right? This 4 is nothing but I. So in this case, I can write this as k plus v is equals to I plus 1. Right? Similarly here, instead of 4, I have to write, here I is 3. So instead of 4, I have to write I plus 1. 3 plus 1 is 4 minus k. So I say v is nothing but I plus 1 minus k. Similarly, here also if I solve this, I get v is equals to I plus 1 minus k. And in both the cases, if you see, I get the same pattern, that is the value that I need to print is I plus 1 minus k. Okay, so I'll just note it down here. The value to be printed is I plus 1 minus k. So what I can conclude is the value to be printed is I plus 1 minus k only for these 3 values. Only for the value of k, which is 1, 2 and 3. It is only applicable for this red area, not for the right hand side. This is true only whenever k is less than equals to 3. See, in all these cases, the k value is less than equals to 3. Okay, so whenever k is less than equals to 3, that is I here. 3 is nothing but I. Whenever k is less than equals to 3 or I actually print this pattern, that is I plus 1 minus k. In other cases, here this is the value of k is 4. So here 4 is greater than 3. So this case is not applicable. Here 5 is greater than 3. This case is not applicable. This is only applicable for these three values wherein k is less than I. So here you see 1 is less than equals to 3. This is true. 2 is less than equals to 3 is also true, and 3 is less than equals to 3 is also true. So I can conclude whenever value of k is less than equals to I have to print this pattern I plus 1 minus k. Okay, so that I can write it here as a code. Okay, how do I write it is very simple. Okay, so I'll write if k is less than equals to I, that means I'll simply print, what do I print? I'll print the value. How do I print the value? It is very simple. I'll print, this is 1, I plus 1 minus k. I plus 1 minus k. This is what I print if it is less than equals to I, if k is less than equals to I. In all other cases, I'll have to print a different pattern. Now I have to look at the decrementing pattern. Okay, let's follow it for the decrementing pattern now. Now here we have taken an example of I equals to 3, line number 3, okay, and I equals to 4. In line number 3, the values of k are 1, 2, 3, 4 and 5. We have already done this part. Okay, now we are concerned about this part wherein k is greater than I. Similarly, in case of I equals to 4, we have already done this part. Okay, this if is doing that part, and now we are concerned about the condition k greater than I, all these three numbers. Okay, so let's see how it works. If you see here, I need to print 2, not 4. Okay, so if I actually subtract 3 from 4, if I write 4 minus 3, so here k is 4, right? So 4 minus I is 3 is equals to 1, but what I need to print is 2, so I need to add one more to it. Okay, so this becomes 2. That means what I'm trying to do is I'm trying to use, this is k, okay, so k minus, this is I plus 1. So this is the pattern, right? If I follow this pattern, I think I shall get the answer. Okay, just verify this with I equals to 4. So let's try to derive this number 3. So in this case, k is how much? In this case, k is 6. Okay, and in this case, I is 4. So what is the value that I need to print? K minus I plus 1. K is 6. 6 minus I is 4 plus 1. Okay, 6 minus 4 is 2. 2 plus 1 is 3. And this is the output 3. So the pattern is very simple. K minus I plus 1 would give me the number. So if this is false, I go to this part, okay, wherein the numbers are actually incrementing. So for incrementing number, what I print is, okay, printf, I print percentage %d, okay, and I print k minus I plus 1, okay, and that's all. Okay, so this will print all my values, and finally I have to print a new line character in each line. So how do I print a new line character? I just have to write printf/n. Okay, so I'll just write here printf/n, and this works fine. It will print this pattern as it is. Okay, printing values here looks little bit complicated, but we can actually simplify this. Okay, so let's see how we can simplify this. Now let's try to see how we can simplify this. Okay, now we have a concern for printing the values that was getting complicated, right? So what if we can have a different loop for printing the decrementing value, okay, and different loop for printing the incrementing value? That would be great, isn't it? Let's have a loop here for printing the decrementing value, and let's have one more loop here for printing the incrementing value. Okay, so let's say this loop is k. Okay, so k, so what is the first value of k? So if I is 3, I'm starting from 3. Very simple. If I is 4, I'm starting from 4, right? So I'm starting from 4 and I'm going up to 1. Starting from I and I'm going up to 1. Starting from I, here I is 3 and going up to 1. So I'm starting from I, okay, and then k should be greater than equals to 1. I'm going up to 1. Each time I'm decrementing the value of k by 1. From 3 it becomes 2, from 2 it becomes 1. Okay, so from I, I'm going up to 1, each time decrementing the value of k by 1, and then I simply write printf. I have to print the value k, %d, and this is k. Very simple, right? So this will take care of my decrementing values. Now let's write one more loop to take care of the incrementing values. Now incrementing values, if you see each time it starts from 2, See, each time it starts from 2. The loop starts from 2, right? So it's very simple. I can write the loop, let's say it's controlled by the variable L. The loop starts from 2. Now where does this loop stop, right? If you just take I equals to 4, okay, I equals to 4, it starts at 2 and goes up to 4. That means it is going up to I, right? You consider I equals to 5, it is going up to I, okay? You consider I equals to 3, it is going up to I. So it is going up to I, so my L, variable L, should always be less than equals to I. It goes up to I, and then I do L plus plus, okay? So I simply write, I print the value of L, printf %d L, okay? So it is always good to go for the easier implementation while you are a beginner, right? So this works fine and it is less complicated than the previous one, but it exactly prints the same pattern, right? So I hope you have understood how pattern problem actually works. Now we're going to write a computer program to demonstrate the same pattern, this pyramid pattern, but we're going to make our code more generic in nature. So let's get started. Okay, so I've already created this program called as pattern pat.c. Okay, I need to display this pattern. I've given this as a comment here. Okay, and we already know that, we have got the outer loop. Okay, that is I loop that takes care of each line. So this is the outer loop. Okay, this is the outer loop that takes care of each line. Inside the outer loop, that is, and now I'm starting the inner loop. J loop will take care of printing all these spaces. So this is the loop that takes care of printing all these spaces. This is the loop that takes care of counting the values down, count down, and printing all those values. And this is the loop, that L loop, that takes care of printing all the values, counting up. Okay, and finally I print a new line. So I repeat this entire thing for each line. Therefore I should be able to get this pattern. So let's see if I'm getting the correct pattern here. Okay, so I'll just compile this code and then I run this. So I get the correct output, right? But now let's try to make this code a little bit more generic. Okay, in this code, it's always printing for 5 lines. But what if I want this to be variable? That means if user supplies the value 4, it should print 4 lines. And if user supplies the value 9, it should print 9 lines. Let's make our program a little bit more generic. So instead of actually having this 5, I need to make this as a variable. Okay, so let's declare one variable n, that is the number of lines. So let's ask the user to enter number of lines. Okay, enter number of lines that you want to be displayed. Okay, and then I'll scan that using a scanf, and let's scan that number of line as an integer in the variable n. Okay, so once this scanning is done, now what I do is I'll have to replace wherever I have 5, because 5 was number of lines. Now I have n number of lines. Replace this by n, replace the 5 by n. Now you go and check, there is this 5 here, 5 minus I, replace this by n minus I. Okay, and there is nowhere else I'm using 5. So I think we are done. Okay, so let's try to compile this code one more time. No errors. Run this. So it is asking me to enter number of lines. So let's enter 3 lines. So it is displaying the same pattern just for 3 lines. Now let me enter 4 lines. So again, working fine. 5 lines, working fine. 9 lines. So it is seamlessly displaying the same pattern in 9 different lines. Okay, so I hope you have understood how this really works. Okay, so the main idea here is not to code it. Coding is the last thing. See, we have not invested much time in coding. The important thing is to actually devise your logic using pen and paper, identify the relationship between inner loop and outer loop, and devise your logic and devise your algorithm. Once that is clear, it is very easy to write a code and implement it. I hope you have learned how to actually approach and solve any given pattern problem in future. That's all in this lecture. Stay tuned.